First, we list out our given values. So mass equals 4 kilograms and tangential velocity equals 6 meters per second. So let's make a free body diagram. Force of tension 1 going this way, force of tension 2 going this way, and force of gravity going downward. Now since we know that it's in the middle, we can label both of these angles as theta. And we can break this up into components. The angles here for both of those should be cosine. So this is ft1 cosine of theta, and this is ft2 cosine of theta. So the one going upwards will be ft1 times sine of theta, and the one going downwards would be ft2 times sine of theta. Now let's draw that better on another free body diagram down here. ft1 sine theta, ft2 sine theta, ft1 sine theta, and ft2 sine theta. Now we don't really know the relative lengths of these two vectors right here. We just know that the sum of these two should equal this because the ball is not moving up or down in the y direction. Now, what other information can we get just from this diagram? If we draw the shape out like a triangle, we know that this length right here is 3 meters, and this can be divided into two congruent triangles. So that means each of these is 3 divided by 2, which is 1.5 meters. We also know that the length of the rope on both sides is 2 meters. And we labeled these angles as theta. So if we just ignore one half of the triangle and focus on this one only, since we know that this line over here is perpendicular to this height right here, we know this is a 90-degree angle. So we can use Pythagorean theorem to find the length of the radius right here. So since this one is the hypotenuse, we'll write 2 squared equals 1.5 squared plus r squared. If we solve for r, that's the square root of 2 squared minus 1.5 squared. So r is approximately 1.3228 ... Similarly, we can use this to find the value of theta. Since this side is the opposite of this angle, we can say that the sine of theta equals opposite over hypotenuse, which is 1.5 over 2. So we can isolate theta and say theta equals the arcsine of 1.5 over 2, which is approximately 48 degrees. So I'm going to add these right here. Radius equals 1.3228 meters, and theta is 48 degrees. Now we can go back here. So let's start by summing our forces in the y direction, which equals force of tension 1 sine of theta. So up is positive, down is negative, minus force of tension 2 sine of theta, minus force of gravity, which equals mass times acceleration. And since there is an acceleration in the y direction, this just equals 0. So we can write that as force of tension 1 sine of theta minus force of tension 2 sine of theta equals force of gravity, which also equals mass times gravity itself. We can factor out a sine theta from both of these, which will leave us with force of tension 1 minus force of tension 2. And we can write this as force of tension 1 minus force of tension 2 equals mass times gravity divided by sine of theta. Similarly, we can sum our forces in the inwards direction since our object here is in rotational motion. So we can write the sum of forces in the in direction equals all the forces that are pointing to the center of the orbit will be positive and the outside will be negative. So these both are positive forces right here. Force of tension 1 times cosine of theta plus force of tension 2 times cosine of theta equal mass times centripetal acceleration. Once again, we can factor out a cosine theta from both of these, leaving us with force of tension 1 plus force of tension 2 equal mass times centripetal acceleration. And we can isolate force of tension 1 plus force of tension 2 equal mass times centripetal acceleration, all divided by the cosine of theta. Adding on to that, we know that centripetal acceleration equals velocity tangential squared over radius. So we can plug that in, and we're left with mass times tangential velocity squared over r equals cosine of theta, which can be simplified as mass times velocity tangential squared over r times cosine of theta. Now we can take this, and we can sum both of these equations together. So we can bring this one right here. Force of tension 1 minus force of tension 2 equals mass times gravity over sine of theta. We can bring this one right here, plus force of tension 1 plus force of tension 2 equals this value right here, mass times vt squared over r times cosine of theta. Since this is a minus and this is a plus, these two cancel out, and we're left with 2 times force of tension 1 equals mass times gravity over sine of theta plus mass times tangential velocity squared over r times cosine of theta. Now we just simply plug in our values, which right here would be 4 times 1.1 over sine of 8 plus 4 times 6 squared over times 1.3233228 times cosine of 8 equals 2 times force tension 1. So this is approximately 2.16.8911428 equals 2 times force of tension 1. Divide both sides by 2 and you get is approximately 108.445 newtons. Now that we've figured out the force of tension 1, which is this force right here, we can just plug it into either of these equations and get the value for force of tension 2. I'm just going to use the force of tension 1 plus force of tension 2 equals mass times vt squared over r times cosine of theta. So force of tension 2 equals that minus force of tension 1, which is approximately 164.571428 minus 108.4457, which leaves us with force of tension 2 is approximately 56.125 newtons. And these are our final answers.